Okay, here's a question where we have to integrate to find the area between two curves. So now we've got two functions. So our two functions, it's easy enough. It's basically this function, sine 2x, minus this function, sine x cos squared x. And just like compound area, the shaded area between the two is going to be the answer. So if we're going to take one function away from the other, let's set up the integral. So set up our integral. We're given limits. It's from 0 to pi over 2. 0 to pi over 2. So first thing, we'll do the first function, which is sine of 2x. And then we're going to subtract the other function, sine x cos squared x dx. Now, because we're subtracting area from area, what we can do is we can split these into two integrals. Okay, so we'll do sine 2x dx minus the integral of sine pi over 2 0 of sine x squared x dx. Okay. Right, so the first one, the first half is the simple one. So we know that sine 2x, okay, this is our ax. So we've got a coefficient there, and if we integrate the coefficient, we know that basically we have to divide by that coefficient, whereas with differentiation we multiply. So if we integrate this, sine 2x dx, that just gives us the derivative. Okay, so sorry, the integral. So basically, if we integrate sine, we get minus cos. So we get minus cos of 2x, but because it's got the coefficient, we divide it by a half, and that gives us minus a half cos 2x. Okay, if we put that into our brackets, because it's a definite integral, put the limits on it, okay, then that's going to give us two brackets, right? So pi cos of 2 times pi over 2 is just cos of pi. So that's going to give us minus a half times cos of pi, which is going to be minus 1. And then we're going to do 0, so cos of 0 is 1. So we have minus a half times 1, which is 1. So that gives us, in total, 1. Okay, so that's that part. Right, now we need to deal with the second half. So right, we've got to decide. This question doesn't tell us how to integrate, so we can choose our own method. So let's choose method 1. Okay, we're going to do the reverse chain rule. Okay, and we know there's two forms. You can either have the derivative of x over function x, or you can have the derivative of x multiplying the function of x. Okay, and basically this one's we're going to guess that this is a log. For this one, we're going to guess that it is a function to the power of n plus 1. Okay, so to do that, we are going to guess that y, the original function, was cos cubed x, which means that dy by dx is equal to minus sine of x times 2 cos squared x. Oh, sorry, 3, not 2. Right. Now I've got that, so that's equal to minus 3 sine x cos squared x. Okay, now we compare this with our original integral. and we'll see that we're missing that. So that means that this must be equal to minus a third of our guess, which was cos cubed. So we've got minus 1/3 cos cubed of x. Okay, so then we can put brackets around this, given our limits. Okay, and if we feed our limits into that, we've got the way we set the answer. So cos of pi over 2, cos of pi over 2 is going to be 0. So I've got 1/3 of 0, that's 0. Okay, and then I'm going to do cos of 0, which is 1 cubed, that's 1, so I've got minus a third times 1, okay, which equals a third. Okay, now remember my function is the first integral minus the second, so my answer is 1 minus a third, that equals 2/3, which is the correct answer. Okay, so now this was method 1. What is method 2? So method 2, rather than doing the reverse chain rule, we can try substitution. Okay, so our integral is sine x cos squared x dx. Now, this time we haven't been told to use substitution, so we've got to decide what to use for u. Well, it would seem to make sense to have cos, as that's squared. So let's have u is cos of x, and then we can do du by dx. Du by dx of that is minus sine x. Okay, remember we want to replace the x's in our integral, so that's basically, that means that du is equal to minus sine x dx. Okay, let's go back to our integral. Okay, so I've got dx here, and I've got sine here, but this is minus sine x dx. So I'm going to rewrite my integral as minus du. So I can replace sine x and dx with minus du, because minus sine x dx is equal to du. Now I've got u squared. That's just cos, that's that. So that means u squared. So that means my integral is minus u squared du. I need some limits. So when x equals pi over 2, that means I want cos pi over 2. U is going to be 0. When x is equal to 0, that means u is cos of 0, which is 1. So my two new limits are 0 and 1. Okay, so now what I have to do is integrate that outside. U squared du, well, that's pretty easy. That means I'm going to have a minus, and I have a third u cubed, and with my limits of 0 to 1. Okay, so again, a few brackets to subtract, make sure we don't make sign errors. So when it's 0, that is 0. When it's 1, 1 cubed is 1. That is a third. Okay, and remember that means I do minus, so that's going to be equal to 1/3. Okay, remember this is just a second integral. And what did we find from the integral before? We found that basically that was a third. So we get exactly the same answer. So you can see either method works. Just for substitution, we have to think about what is an appropriate substitution, as we're not instructed to do that in the question.